Jai Hind everyone. So again I welcome you all to the Basic Electrical Engineering course. So in today's lecture I am going to cover two important topics related to the fifth unit, that our first one will be the earthing and the second will be the types of wires and cables. So let's start with the first topic, that is earthing. So basically why earthing is required? So all the people living or working in residential, commercial or industrial installation, particularly the operators and the personnel who are in close operation and contact with the electrical system and machineries, should essentially be protected against the possible electrification. So to achieve this protection, earthing system and installation is designed and installed according to the standard requirements. So as we know that earthing, it is a very common term that is used nowadays. So the basic purpose of earthing, as mentioned in this particular slide, it is to protect any particular human being, especially those particular operators who are working near any electrical equipment. So this is basically the concept of earthing. Now, how we define earthing? It is the process of connecting metallic bodies of all the electrical apparatus and equipment to huge mass of earth by a wire having negligible resistance. It is called earthing. Like you might have seen here in your home also, if you refer to any particular socket, so in a socket, whether it is 6 ampere or 15 ampere socket, you will find there will be 3 terminals. So the lower two are generally used for phase and neutral, and the upper having more cross sectional area, that is called earthing terminal. So as we can see, the resistance, it is inversely proportional to the area of cross section. That's why to have a least resistance path for the flow of current under faulty situations, we generally provide earthing terminal. Now that particular earthing terminal from that socket, it is generally connected directly with the help of a wire to the earth. So this process is called earthing. Now what are the qualities of good earthing? So any particular earthing, it should satisfy these particular conditions, that first it must be of electrical low resistance. So we know that if the value of the resistance will be low, it can handle a very high amount of faulty or fault current. So the first and foremost condition is that for good earthing, we should have a low electrical resistance path. Second thing is that it should be corrosion free, because we know that again we are using any particular wire, so it will be a metallic wire. So with time, if it gets corroded, then it will lose its mechanical strength and it cannot be used for future purpose. So that's why it should be almost corrosion free. That's why we generally use galvanized iron to have this type of good corrosion resistance. The third is it must be capable to dissipate high fault current repeatedly, because that particular wire, again the wiring that is done, it is for a number of years. So that particular wire, it should be able to carry the fault current for a long duration of time. So all these are the qualities that are required for a good earthing. Now next, again we will discuss in detail why or what is the purpose of earthing. So first, as we have discussed earlier also, that to save human life from danger of electric shock or death, we generally provide an alternative path for the flow of current to flow, so that the life of any particular human being, it is not endangered. So again, as I told you from the example, that suppose we are using an electrical iron and by any particular chance, under a faulty condition, that particular wire, it comes in contact with the metallic part of the electric iron. Now, under that particular situation, the metallic part, it will accumulate the charge, and if by any chance, if any human being, they come in contact with that metallic part, so he or she may get a shock. So, to avoid this particular situation, this earthing provides an alternative path for the flow of current, so that the charge is not accumulated in that metallic portion under the faulty condition. Second thing, to protect building, machinery and electrical appliance under fault condition, that is to ensure that all exposed conductive parts do not reach to a dangerous potential. So, if this is very much required that all these particular machineries, the voltage level is maintained at a prescribed limit. If the voltage level increases, naturally the short circuit condition may happen. So, again the purpose of earthing is to avoid the short circuit condition also. And the third important purpose of this earthing is to provide safe path to dissipate lighting and short circuit currents. So, you all might have seen lighting occurring during especially the rainy season. So, this particular lighting, it has a very high level of voltage, and whenever this particular lighting strikes on the earth, so there might be a chances any particular near object where this particular light strikes, so it may damage that particular equipment. So, especially for any electrical substation, we generally provide these particular lightning arresters. So, the only objective of these particular lightning arrestor, again they are grounded. So, to provide a safe path for the flow of this current. The last is to provide a stable platform for the operation of sensitive electronic equipment. That means we know that electronic equipment, they are very sensitive to the voltage fluctuation. Now, to maintain the voltage at any electrical part of the system, we generally use this particular earthing concept. So, these are the important points that are required for this particular earthing. Now, with the help of this particular example, I will discuss with you how with the help of earthing a life can be saved. So, in the first case, as you can see here in this figure, it is shown that this electrical appliance, it is not properly earthed. So, if under any faulty condition, this particular live wire, if it comes in contact with this particular electrical equipment, so it will store some charge, and any operator, when he or she will come in contact with this particular electrical appliance, then they might get a shock. So, it can be life threatening also. As you can see here, the current is directly passing through the human body. In the second case, if this particular electrical equipment, it is properly earthed, as you can see here, so under the faulty condition also, the current will get an alternating path directly to the earth with the help of this earthing. So, if any particular person, they touch this particular equipment also, then also that particular person will not experience any particular shock. So, this is all about the introduction of earthing. Now, I will discuss what are the various methods of conventional earthing. So, earthing can be done in either of these four ways. Depending upon the requirement, we can go for plate earthing, pipe earthing, rod earthing and strip earthing. So, let us discuss all of them one by one. So, first is plate earthing. So, as the name suggests, in this particular case, we take the help of a copper plate or a iron plate. So, in this type of earthing, either a copper or a GI, that means galvanized iron, that is buried under the ground at a depth of not less than 3 meters from the ground level. The earth plate is embedded in alternating layer of coke and salt for minimum thickness of 15 centimeter. So basically this charcoal and salt, it has a property to retain moisture over a long period of time. Generally, that's why we go for this particular coal and this charcoal and this salt mixture. So it is again embedded, that plate is embedded in this particular coal, salt and charcoal mixture. So the earth wire, that may be the copper wire or GI wire, is securely bolted to an earth plate with the help of bolt nut and washer made of copper in case of copper plate earthing, and GI in case of GI, that is galvanized iron plate earthing. So here in this figure you can see this is the plate. Copper, it can be a copper plate, but copper is very expensive, so the alternative, cheap alternative is your galvanized iron. So this particular plate, it is embedded in this coal and charcoal mixture. So coal and charcoal mixture is present over this particular plate to retain the moisture, because if the moisture level will be high, that means the resistance can be kept low. So that is the main use of this particular earthing. So this type of plate earthing, it is generally used in case of electrical substation. So this is the first type of earthing. Again, from time to time, we generally pour water with the help of this funnel to retain the moisture of the soil. So this is basically the first type of earthing, that is the plate earthing. So second is the pipe earthing. Now this pipe earthing, it is very popular. The reason is that it is a cheap method, and a GI pipe of 38 millimeter diameter and 2 millimeter length is embedded vertically in the ground to work as an electrode, but depth depend upon the soil condition. So you can change the length of this particular pipe depending upon the soil conditions. So in this case, the wire is embedded up to the wet soil. Again, that is basic requirement, because we know that to maintain a conductivity, we should embed that particular wire up to the wet soil. So the pit area around the GI pipe filled with salt and charcoal mixture, that I told you earlier also, to retain the moisture in the soil, we generally use this coal and salt mixture. Now this particular heavy current can be passed through this particular pipe earthing as compared to the plate earthing. So the current handling capacity of this pipe earthing is better as compared to this plate earthing. So because of this particular reason, this pipe earthing, as it is cheap also and it is quite effective, it is generally used for household purposes also. So if you see as the figure of this particular thing, so here only thing is that the plate earthing, the plate is replaced by this particular pipe, and this is a perforated pipe. So from time to time we will pour some water into this particular pipe, and this pipe again, it is embedded in the coal and salt mixture. So the moisture will be maintained and the resistance will be kept low. So the resistance should be kept as low as 1 ohm in this particular case. Third type is rod earthing. So again, as the name suggests, instead of this pipe we will use rods. So in this system of earthing, 12.5 millimeter diameter solid rods of copper or GI can be used, and they are vertically driven into the earth in order to increase the embedded length of the electrode under the ground, which are sometimes necessary to reduce the earth resistance to the desired level. One or more number of rods can be inserted with the help of hammering. So basically this rod type of earthing, it is generally used for sandy nature. So in case of desert, we generally go for rod type of earthing, because plate earthing and pipe earthing, they are not possible in the sandy nature. Next is strip earthing. So basically in case of strip earthing, we make a strip of different wires and we make a mesh out of that. So this particular strip type of earthing, it is generally suitable in case of rocky situation. So in case of hilly areas, we generally go for strip earthing, because again digging in the rocky condition, it is very difficult, and we know that in case of hilly areas, because of the rocky condition, the earth resistance is very high. So if we want to decrease the value of the earth resistance, then we have to go for the strip earthing. So in this system of earthing, strip electrode of cross section not less than 25 millimeter into 1.6 millimeter of copper, or 25 millimeter into 4 millimeter of galvanized iron or steel are buried in the horizontal trenches of minimum depth of 0.5 meter. So if round conductor are used, then their cross-sectional area shall not be smaller than 3 millimeter square for copper, and for galvanized iron it should not be less than 6 millimeter square. The length of the buried conductor shall be sufficient to give the required earth resistance of 0.5 ohm to 1.5 ohm. So as I told you, the earth resistance should be kept minimum. That is the main use of this earthing. So you can see here the earth resistance should be maintained as low as 1 ohm or 0.5 ohm. It shall, however, be not less than 15 meter. So that particular length of that particular strip earthing, it should be embedded at least up to 15 meter. The electrode shall be as wide distributed as possible in a single straight or circular trenches radiated from one point. So as I told you, that particular wire, mesh of the wire, it is again used for this particular type of wiring. So that's why it is called your strip earthing, and that particular strip, it takes the shape of any particular trench. So this type of earthing is used in rocky soil. As I told you that in case of your rocky condition, the value of resistance is very high. So that's why we have this type of strip type of earthing. With the help of this, we increases the cross sectional area, and with the help of that, we can reduce the earth resistance to the required level. So depending upon the application, we can opt any type of earthing that we have discussed here. Now with this, I finish with the earthing. The next topic is types of wires and cable. So again, all of you are familiar, you might have seen wires and cable in your day-to-day life. So basic difference between wire and cable, as you can see here, in case of wire, you have one conductor, and in case of cable, it will be a bunch of conductor, and that is wrapped within a insulation. So this is the basic difference between a wire and a cable. So the term wire and cable are used to describe the same thing, but they are actually quite different. Wire is a single electrical conductor, as I have shown here. In case of wire, you can see a single conductor. It is a stranded conductor. And whereas in case of cable, it is a group of wire that are wrapped in a protective layer that is called sheathing. The term cable in an electrical context like wire are used to carry the electrical currents. Now first we will discuss about the types of wires and cables. So basically there are three types of wires that are generally used. First is VIR, that is vulcanized Indian rubber. Second is TRS, that is tough rubber sheeted wire, and third is PVC, that is polyvinyl chloride. So in the earlier years, in 1980s, 90s, this VIR was very popular. Again, due to some limitation of this VIR, this TRS was invented, and the latest one that we are using in our day-to-day life these days, that is PVC. So VIR, as the name suggests, it is Indian rubber. So it is a vulcanized Indian rubber. So VIR wire mainly consists of a tin conductor having rubber coating. So tinning is done so that it should prevent the sticking of the rubber to the conductor. Thickness of the rubber depends upon the operating voltage. As we know that the insulation requirements in case of wire, it depends upon the operating voltage level. a cotton layer is used over the rubber insulation to protect against the moisture. And finally, the wire is finished with the help of wax for cleanliness. Nowadays, these wires are not used since a better quality wires are available at a cheaper rate. So, this is the first type of wire, that is vulcanized Indian rubber. But the main reason we have discontinued with this type of wire is that their time, again the lifetime was very small. So, after certain number of years, it was found that there were some cracks that were developed on the insulator. So, the life of this particular wire, that is quite short as compared to other one. That's why now these particular vulcanized Indian rubbers, they are almost obsolete. Second one was TRS, tough rubber sheathed. So, that means again in this type of wire, modification was done in VIR wire. So, it consists of ordinary rubber coated conductors with an additional sheath of tough rubber. So, as you can see here, again here in this case, the outer layer, one more protective layer was provided, that was of thick layer of rubber. So, this particular layer was quite tough, that's why it is called tough rubber sheathed. So, the additional advantage provided by this tough rubber was, it will again protect that particular wire from wear and tear. So, the life of that was again more as compared to the first one. But nowadays the most popular one are PVC wire. So, we know that it is polyvinyl chloride. So, PVC, they have the advantage of moisture proof. Second, they are tough. Third is durable, and fourth, it is chemically inert. So, due to all these particular advantages, we generally go for these particular PVC wires nowadays. So, you can see here this outer insulation, we only require one insulation outside, that will be the PVC insulation. Now, next is types of cables. So, there are more than 20 different types of cable that are available in the market depending upon the industrial use. Some of the most commonly used I have included in these slides. So, first one is called non-metallic sheathed cable. So, these cables are known as NM cables also. So, non-metallic sheath cable is used in most of the homes and has 2-3 conductors, each with plastic insulation and a bare ground wire. So, the individual wires are covered with another layer of non-metallic sheathing. Since it is relatively cheap and available in the rating of 15 ampere, 20 ampere, so this type of wire is generally used for house wiring. So, you can see here you can see that there are these insulated wires. So, they are generally used for phase and neutral, and the third one is your earth wire. So, this is the first type, that is non-metallic. Second, we can have this underground power cable also. So, this type of wire cable, they are high water resistance. So, they are generally used in underground conditions because they are damp proof also. So, you can use this type of wire. Again, here you can see it has different layers. So, to transmit power over a long distance, we generally use this particular underground power cables. So, here you can see it has different layers because here the current carrying capability will be very high, and these particular wires, they are underground. So, it has to be provided with different protective layers. So, the starting with, you can see the first one is the conductor. So, conductor can be your copper conductor or aluminum conductor. Over that, we have a conductor screen, then insulation layer is there, then we have an insulation screen, then metallic sheath, then we have bedding, armoring, and last one is serving. So, I will discuss all these one by one. First is the conductor screen. So, conductor screening is generally used in case of this particular high voltage cables to maintain uniform electric field and to minimize the electrostatic stresses. So, here the first protective layer is this conductor screen. Over this we have insulation. Now, this particular insulation can be provided by either VIR or by using PVC, or the latest one is this XLPE, that is called cross-link polyethylene. So depending upon the voltage level and the cost, we can choose among all these particular insulation material. Next is the insulation screen. Again, this particular insulation, it is subjected to moisture because it is underground and the various chemicals are also present in the soil. So to protect this insulation, we generally use this insulation screen. Over that, we have this metallic sheet, because we know that this particular cable has to be put underground, so it will go under mechanical stress also, and it will be exposed to chemicals also. So to save this from the mechanical stress and from the chemical attack, we generally provide a metallic sheet to this particular conductor. Now over that, we have bedding. Again, we are using this metallic sheet. It is generally made up of iron. So again, it will be exposed to the moisture as well as the different chemicals. So to save these particular metallic sheet, okay, from corrosion, we generally provide a bedding. So bedding, it is generally provided with the help of jute, because we know that a jute, it has a good property to absorb the moisture. So it will provide a protective layer to this metallic sheet also. Over that, we have armoring also. Now this particular armoring, it is again, we have a steel tape that is wound over this particular cable. So again, the purpose of this armoring is to protect this cable from the mechanical stress it will face during the laying of this cable. And the last one is serving. Again, this particular metallic sheet, that is called armoring, it has to be saved from the external attack of moisture and chemical. So we generally provide this serving. Again, this serving is generally made up of jute. So, or you can use a PVC material over this, so that to protect this particular steel from the atmospheric containment and agents. So this is the second one, that is the underground cable. The third one is metallic sheeted cable. Now this type of cable, you might have seen, it is generally used for various power appliances. So here it is also known as armored cable. So metal sheeted cable are often used to supply main electricity or for the large appliances. So they feature three main stranded copper wires, one for the phase, second one is for the neutral, and the third one is for the ground. So a PVC bedding is generally used for the insulation purpose. Over this, we have this steel wire sheeting, and that is generally used because these particular wires, they are generally used for outdoor application and high stress application. So to protect them from moisture or any other severe condition, we generally use this metallic sheeted cable. So this is the figure for the metallic sheeted cable. Again, you can see the outer periphery, it is a metallic sheet that will protect this particular cable. So basic purpose is to provide a more mechanical strength when this type of cable is used for outdoor applications. The last one is the coaxial cable. So coaxial cable, I hope you have seen, this is generally used in case of communication. So a coaxial cable features a tubular insulating layer that protects an inner conductor, which is further surrounded by a tubular conducting shield, and might also feature an outer sheet for extra insulation. So these cables are normally used for carrying the television signals and connecting the audio video equipment. So this is the figure for this coaxial cable. Here you can see again the innermost one is the copper wire. So over that, we have this particular screen, insulation screen, that is provided to avoid the electromagnetic interference, because this type of cable is generally used for video, so noise should be reduced. So this screen is provided over that, and over that we have this particular copper mesh to avoid the EMI, electromagnetic interference, and the outer one, again it can be a PVC material to protect this particular copper mesh. So this is all about the types of wires and cables. Thank you.